Hello, greetings, welcome. So we just formulated our integer programming problem for our second example from week 8 from chapter 4 on integer programming. And so in this screencast, I'm going to go and solve it using LibreOffice Calc. Okay. So to give us a head start, I went and I typed up the table as it's given in the problem. And so what I'm going to do next is I'm going to add two columns for our variables. Okay, so xi, so the number of units produced on each machine. And so I'll start with guesses, say 1, 2, and 3. And then yi, so that's our binary variable, just indicating if a given machine is used. Okay, and so our objective is going to be to minimize our cost. Okay, so let's go ahead and calculate our cost. So our cost will be equal to the number of units made on each machine times the per unit cost. Plus the setup cost times our variable that's going to determine or indicate whether or not a machine is used. Okay, so there's our objective function. And then from there, we will begin to list out our constraints. Okay, so going through it, okay, our set of constraints were going to be the total desired production. Okay, so let's start with that. So let's start with total production. So we want that the total number of units produced, okay, was at least 2,000. So put 2,000 on the right hand side. And then we're going to have our capacity. Okay. Okay. So on the left hand side I had x1, x2, and x3. And on the right hand side I had the capacity times our variable indicating of whether or not that machine was used. So capacity times that variable indicating whether or not we're using a specific machine. And then we had this minimum amount that we could make in a given run on each machine of 500 units. Okay, and so on the left hand side again we'll have the number of units produced on machines 1, 2, and 3. And on the right hand side it'll be 500's the min, again times that variable indicating if we're using a machine or not. Okay, so I have all of our capacities. Then we'll have non-negativity. We'll have our integer constraint. So all of our variables will be integers, all of our variables will be non-negative, and then additionally this constraint that y1, y2, and y3 are all less than or equal to 0, because combined with our non-negativity constraint that y1, y2, and y3 are greater than or equal to 0, it must be that those equalities can only be satisfied if y is equal to 0 or 1. Okay, and I'll just do that as a blanket constraint the way we have the problem set up. Okay, so I'm going to go Tool, Solver. Okay, and I'll set it up Excel style, I suppose. Okay, so we want to minimize our cost. Okay, we have all 6 of these variables. Okay, so our total production needs to be greater than or equal to 2,000. The number of units produced on each machine needs to be less than or equal to the capacity. All right, and so We either have the maximum capacity of that machine or 0 if the machine's not used. Bam. We have that the minimum number in a given run is greater than that minimum run number. To make it look more like Excel, I'm going to do integer constraints this way. So I'm going to require that all of our variables are integers. Okay. And I'll apply non-negativity just here. Okay, we could have done integers via the checkbox as well. And then I'm going to require that those y variables are less than or equal to 1, since they're already greater than or equal to 0 via non-negativity. And if I solve, let's see, I get a result. Okay, so we were given an answer here. Let's see if we've got it. So we get we get 11,300. So we get 600 units of 1, 600, 500, 900, 600, 500, 900 for a cost of $11,300. Okay, cool. So we got it. That's it. And we could play around with how Solver is set up just as well. These first 3 are less than or equal to capacity. These 3 are greater than or equal to the right-hand side. We could have done that as a block. We could have done non-negativity as a block by selecting everything. So there's plenty of different ways to set it up. Okay, but there you go. Hope that helps.